Welcome to Web Handling. My name is Dave Roisum. We continue this series on DFM for web handling to talk about what may be the property of greatest opportunity for some, and no doubt the greatest risk for all. That is, geometries that are not uniform across the width and/or down the length of the web. Stay tuned. In the last clip, we discussed the possibly debilitating results for unintentional variations in thickness that may be less than a mere 1%. Bagginess is one well-known and well-studied example. There are others. Here, we are talking about intentional variations of thickness and other properties that are much, much greater than that. The question we would ask is, how can we possibly do that without troubles? Well, I will offer some tricks at the end of this clip. For now, I could say that the confidence of the web handler to predict troubles is greatly reduced. Again, for reasons I will get to shortly. Yet, there is great motivation to try. All sorts of products are moving from sheet to web to enjoy the economies of scale. Some products are new to web handling. Some products are totally new in every sense of the word. In any case, the motivations are mighty. The economies of scale by going web instead of sheet. Just a few examples that are doing this right at this moment can be found in electronics, food, pharma, and the medical industries. One advantage that they have is that they don't know web handling, and thus would not know that you can't do that. They might try and find that you actually can do that. One disadvantage they have is that they don't know web handling. They might find out that you actually can't do that. At least not with the time and energies they have to work with. It is difficult to be precise on the risk for odd geometries, other than to list general risk areas. These include path control, winding, and wrinkling, and actually many others. This is the time for much humility on the part of the web handlers. That is, because we base most of our rules of thumb and all of our sciences on the assumption of homogeneity across the width and down the length. So web handlers need to be willing to break these so-called rules. Product process developers need to learn web handling, but then to just try something and see what happens. Please allow plenty of time to iterate the design of both product and process, because you are off the map and beyond the tails of the distribution in many key ways. Also, be prepared for failure, both short and long term, because that happens even in traditional web industries on some new products. Profile is normally meant to be a variation of something across the width, where that something could be thickness, modulus, or some other property. Less common word usage is downweb profile variation. Let us take the example of thickness as an easy-to-relate-to property. Intentional thickness variations could be as small as a thin layer of printing ink on a thick laminate with 4 to 6 layers. Even here, we can have winding troubles such as bagginess. However, at the other extreme may be something like blister packs. This would be at best marginally windable, and perhaps not windable at all. In addition to relative thickness variation as a metric of risk, we could also consider relative area. Usually the extremes are easiest to handle. The risk of any of these variations are in the areas already mentioned. Asymmetry is almost certainly going to be risky well beyond the profile listed earlier. Sometimes you can put too wide and slit down the middle later to avoid this asymmetry. However, even this may have its own set of risks, as we will see in the next slide. There may be a big difference in the risk of thick or stiff edges versus centers. In general, stiff edges misbehave as a web by acting like two separate webs and wrinkling in the middle when they move inward just the tiniest bit. In general, thick centers wind a bit better, but better is only a relative term. They will never wind well. Similar to the edges versus center problems, we have 1-up versus 2-up. Two lanes greatly risk wrinkling and registration issues. Sometimes, as we discussed in great detail in Web 101, these clips and elsewhere, it may be much easier to go fast than it is to go wide. For sure, this is the case from a purely web handling perspective. Another set of risks occurs when the product is also discontinuous in length. Here, as one example, we might need to upsize roller and core radius even more than a continuous product to avoid misbehaving at the cross lanes. This is a bend radius issue. The step and repeat industry is a very large market segment that can be found in many product categories. Here you will see many opportunities for value added as well as many risky behaviors. One example is heat sealing, because it distorts the web in thickness, length, bagginess, and other key ways. However, in all these cases, we are not saying don't. Only be careful, especially if you're doing something new to you or new to the industry. Here we finish with just a few of the tricks that you might try for odd geometries. In fact, they might even work better for odd geometries than they do for traditional webs. Some, such as precisions, may offer an opportunity. Hair's breadth roller tolerances may not be required. This can make some sense if, for example, you have products that vary by several percent in thickness, because that will dominate behavior. We also might reduce tensions way below the 5 to 25% of web or perf strength that is used on more traditional materials. Of course, path control will go to heck, but that is actually another opportunity. Because non-traditional web products tend to be stiffer and thicker, we might be able to use simple adjustable roller collars or slats to guide the web instead of the very complicated and very expensive active guides that traditional webs use. Finally, if bend radius is a problem, we might choose a straight-through path and avoiding winding altogether by going roll to sheet rather than roll to roll. However, the number one trick is to allow plenty of time and money to try different things. You will never know unless you try, and try again. Thank you so very much for watching this module in my Plant Practical video series. Stay tuned for the next clip where we will talk about the bigger picture of product, process, and machine design.